Hi, this is Anand from TrueFoundry, and today we'll talk about the AI Gateway and walk through the features on the platform. The AI Gateway is a centralized control plane for Agentic AI. It manages interactions between LLMs and applications, offering unified access, security, observability, and control. You can audit each step of the complex workflow of building agents and RAGs with the tracing capability. There are security and access controls with centralized API key management, RBAC, and rate limiting. There is also fallback and load balancing for maintaining high availability and managing cost, quality, and latency. Guardrails are available for ensuring that PIA information is appropriately handled and ensuring bias and fairness policies are aligned with. There is caching and optimization for maintaining low latency as well as optimizing costs. And you can monitor the cost and usage as well at a team level, at a user level, at a model level, and at any other metadata level that you want to mention. While the gateway provides a unified access to LLMs, it is also a unified access layer for tools via the MCP protocol as well as agents via the A2A protocol, which is increasingly becoming popular and relevant. The applications can be RAG applications, agents, or chatbots. Now let's go to a quick demo. When you log into the platform, this is what you would see, and we will go to the AI Gateway directly. The playground feature offers a number of features. On the left, you can select the model. Here, a lot of models have already been made available, which have been added in the models tab. So these are showing up here. You can either search or you can scroll down and select according to the model provider and the model type. Let me go ahead with Gamma 2. After this, you can also select the different configurations, which is in terms of temperature, maximum tokens, streaming mode, stop sequences where the generation will stop once the stop sequence is encountered, or whether the logs should be stored. When any of these configurations is changed mid-chat, the new response aligns with this particular configuration. Now let's take a simple example. You can see the response has been generated and the tokens involved is 255 here, and the request latency is also mentioned. On the left, you can add multiple additional things like input variables, which are useful for saving this as a prompt template. You can add MCP servers. Here, common tools are managed and provided by TrueFoundry, such as web search, code executions, web scraping, etc. But you have a lot of other MCP servers which are shown here, but which need to be added by you first and which will show up on the playground after that. MCP servers are especially useful for working with tools and which enable the agentic capability. Input guardrails can be added and a few providers are shown here, but you can always add your own guardrails. Similarly, with the output guardrails, you can also add a few guardrails here. Input guardrails act as filters. When the input prompt is getting passed into the LLM, they sit in between, and output guardrails act as filters between the LLM and the response. Finally, structured output capability is also here, where you can mention your schema, but first adding a sample schema and then updating this. And the outputs will always be aligned with this structured output. Once you have done all of this, you can save the prompt, and this will be saved to the repository, and you can load this after that and resume the session very quickly. Let me do something similar to that. Let me load up an existing saved prompt. And I'm selecting the version 1 here. The version capabilities are very useful because prompts should be versioned and managed accordingly. Now this is dynamically switched to GPT-4o, and you can see a number of MCP servers were added in this prompt instance. This is a calendar system prompt which has been mentioned, and this prompt template can be used across your organization as an example. And you can do multiple versioning and prompt management, which is a very useful feature. And once you publish this, this will go on to the agent apps, which we will shortly cover. The recent tab shows the recent chat history, where you can see what all chats you have actually done in the past, and you can always click to that and the session continuity will be maintained as per that session. You can also check the code snippet, where you can see that if you want to use the same particular configuration in the playground within your code, you can use via the OpenAI library, LangChain library, as well as different integrations that we are already providing. You have a unified API key which you can always use, and you do not need to switch API keys when connecting to different model providers and models. Now coming to the models tab, this is where you actually need to configure the model provider and the models before going to the playground to play with it. You can add a new account. Let me add a AWS Bedrock account. You can add the name, you can add the collaborators, and you can manage the access control here. The manager can do everything and the user can only use the models. They will not be able to add models or even change permissions here. This can always be applied using a YAML where we enable a CLI feature. You can use the TrueFoundry CLI and you can basically update all of this account configurations using the YAML and directly apply it. Next, coming to the monitor tab, this shows a lot of metrics firstly by models, by users, by teams, by configurations, and specific metadata that you might have specified, such as environment or customer names. This is useful if you are dealing with a lot of customers. The metrics involve total input tokens, output tokens, request counts, and the total cost of tokens, and very specific latency metrics like end-to-end request latency at a P99, P90 or P50 level, time to first token, inter-token latency, request per second, and so on. You can filter this according to the timeline that you are looking at. Coming to requests, this is a more granular feature where you can inspect each request and you can also fetch this information via the API, which will enable you to build your own custom metrics on top of it. Coming to MCP servers, these are some of the sample MCP servers which have been added, and you can add a new MCP server group, right, with certain access control and with certain MCP servers. Guardrails are also available where some of these guardrails are currently shown as an example. You can add a new guardrails group and we offer multiple integrations with OpenAI moderation, AWS Bedrock, custom guardrails, Azure PII, Azure content safety, and so on. Coming to the agent apps, this is an extension of the playground feature where once the particular prompt has been published, remember the prompt plus the tool is acting as an agent, right? So the system prompt once it's mentioned and the tools as well as the model configurations like temperature, the guardrails and the structured output, all of them combined basically emulate an agent, and once it's published it shows up here. The benefit and the usage of this particular functionality is when you click try app, this opens up a sandbox environment where you can only play around with the agent. You will no longer be able to change the configurations like we talked about in the playground. This is useful especially for UAT use cases. Finally, coming to configurations, which is an essential feature of the AI Gateway. Here you can mention certain configs like rate limiting, where you want to rate limit by the specific model type or by the user or the team, as well as by specific metadata that you have specifically mentioned. Then there are fallbacks that you can configure. Fallbacks and retries are especially useful because there can be service downtimes and outages with very large model providers like OpenAI and Anthropic as well. So to ensure business continuity, this is especially essential. In this example, the model has been configured as GPT 3.5 Turbo, which let's say it is in use. And when one of these response status codes is encountered, the fallback model gets triggered. Now let's say this fallback model GPT-4 is also failing. You can have multiple fallback models already pre-configured here, which will be updated one by one. Next, we have load balancing, which is useful when you want to route models dynamically or via rules. We offer three kinds of load balancing at a high level. One is a weight-based routing where you can mention, let's say 90% of the traffic should go to Llama 3.2 and remaining 10% should go to OpenAI GPT-4. So the traffic will be split accordingly. Second is a latency-based routing because there are latency variances across models across time. So the latency for a model does not remain the same, it does vary. The latency-based routing is a dynamic feature which we provide where the traffic will be routed to the lowest latency model at any point in time. Finally, there is also a priority-based routing, and all of that configuration can be mentioned here. Next, we have guardrails. Like we discussed, you can mention guardrails as a configuration here. And finally, you have budget limiting features that you can also mention the rules here. All of this, remember, can be applied using YAML. which makes it especially useful for developers. Finally, all in all, the AI Gateway acts as a centralized control plane for building agentic AI applications in your enterprise, where you can govern, you have a secure way of using and leveraging generative AI in your organization. Thank you.